Hi everyone, let's talk about vectors. In this video, we are just going to touch on what vectors are, some examples, how we represent these objects both geometrically and algebraically, some basic terminology associated with these objects, and also we need to make sure that we are all on the same page as far as the notation we are going to use for these objects. So the first question is, what is a vector? And if you read the book, and I think you can actually answer this question, but here it is. So in the most basic sense, a vector is just something that has both magnitude and direction. And if you have taken a class like linear algebra before, you know that vectors in mathematics can actually be many different things. But for us though, we're just going to focus on this idea that a vector is something that we use in discipline like physics, very useful, and these things have both magnitude and direction. So I already mentioned physics, but some examples that you might have come across in other classes of vectors might be something like force, which has both magnitude and direction, like gravitational force, and also velocity, displacement, right? So if we just talk about speed of some object, we are only talking about the magnitude. But if we incorporate which direction the object might be moving, then now we're talking about the velocity. Same thing with displacement, right? It's not the distance, but we are incorporating the notion of direction for that. So vectors actually happen in many different ways. So how can we represent these objects so we can work with them? And one way to do that is to use this intuitive idea that if something has both magnitude and direction, then why not use an arrow, right? So here are some vectors represented using arrows. I have two vectors in two-dimensional space and also one three-dimensional vector here. In this kind of representation, we simply use the length of the arrow to represent the magnitude of that vector. And of course, the direction of the arrow is the direction of the vector that they represent. So let's label these vectors. Now, when we are going to represent something that is a vector, we need to indicate that that is a vector by putting an arrow above the letter that we use. So if we want to call this vector u, for example, to indicate the fact that it is a vector, we're going to put the arrow above it. And let's call this one vector v. And let's call this three-dimensional one. Let's say this is going to be vector w, for example. Now, in books, and this is the same way in our book, but sometimes they only use the bold face to indicate the fact that those are vectors. But since when we are writing by hand, it's hard to distinguish unless we have arrows. So make sure that you do the same thing when you are trying to do these by hand. Another way to represent vectors is to use components. Components indicate how you would have to move along the direction of each coordinate axis in order to go from the initial point of a vector to the terminal point of the vector. So for example, if I'm looking at this vector v, looking at the initial point here and the terminal point right there, I would have to go in the x direction like so, and let's say that this change is indicated by a, and move up in the y direction by b. So if this is the case, then vector v would be represented by the bracket a comma b. So these values a and b are called components. And the way that we order the components, that's exactly the same way that we order the coordinate axes. It is directed, however. So for example, if I look at this vector u, and let's just say for the sake of argument, if I were to go from this initial point to the terminal point, I would have to go down, and I'm just going to come up with a number here. Let's say that I am going down by 2 units here, and in the x direction I would have to go down also by 2 units. Then in this case, vector u would be described by -2, -2. So again, the first component indicate that the change in the x direction, and the second component indicates the change in the y direction. And you can do the same thing for three-dimensional vector. So for example, suppose that the going from this initial point to the terminal point, in this case looks like x direction is changing by, say, this is by a. Y direction, let's say that this change right here is by b, and the z value is being changed, let's say, so maybe it's about here, is going to be by increased by c, for example, then w is going to be described by a comma b comma c. So this is a very convenient way to describe vectors, especially because using arrows we can only do it for 2-dimension and the 3-dimension, and of course you know that above 3-dimension we cannot try to describe vectors using arrows anymore. And in general though, if we are dealing with the higher dimensional vector, vector v can include as many components as it needs to. So let's say it might be something like v1 comma v2 all the way up to n components if we are trying to represent a vector in n-dimensional space. Another reason components are useful is when we are trying to look at the magnitude of a vector, right? So again, vectors are something that have both magnitude and the direction. And of course the components definitely help you understand the direction, but also it helps you to find the magnitude. And I want to introduce another notation here, but if you are talking about the magnitude of a vector, so let's say again, we want to look at this vector v that I have over here, then the magnitude of this vector, we put the absolute value symbol around it. So this is indicating the magnitude. And if you think about the fact that once we have the components, since this is basically a right triangle, so you can compute the magnitude of that vector by basically applying the Pythagorean theorem. So you can see that magnitude of a vector using components can be computed easily. And you can do the same thing for any dimensional vector. So if I want to calculate the magnitude for this vector w, then, and you remember the distance formula from the three-dimensional space, this is going to be a squared plus b squared plus c squared, so on and so forth. I want to end this video by talking about one more concept related to vectors. I have here 5 arrows drawn in two-dimensional coordinate system. They all have the same length and they all have the same direction. And one thing that's important here is that as vectors, they represent exactly the same vector. And in fact, if I were to write the vector, say we're going to call this thing vector u, then they all have exactly the same component form 3, 2. And so it really does not matter where the vector initiates. Initial point of a vector does not matter. What really matters is the direction and the magnitude. So writing it in the component form, they should have exactly the same corresponding components. Now, of all the arrows that you can draw to represent exactly the same vector, this one that originates or initiates at the origin, this is called the position vector. So position vector is the one that has the initial point at the origin and the terminal point. These vectors have exactly the same coordinates as the components of the vector, because the terminal point of this vector is 3, 2, exactly the same as the components of the vector that we want to represent. So we're going to be using these position vectors a lot. This is going to be the easiest way to visualize things that are being represented by vectors. So make sure that you know the terminology position vector when it comes up.